last video we have seen insertion sort. Today we will see merge sort, how the merge sort will work, and what is the concept of merge sort. The merge sort works on the divide and conquer method. What is divide and conquer method? Divide and conquer method is first the basic problem. That's a problem. See the problem. If the problem is large, we divide that problem into sub problem. So again that sub problem is divided into again sub problem. So until we get the problem becomes very small, we will divide the problem. And once the problem is small, we will try to solve the each sub problems, and we will merge one by one. So we will get the what? We will get the solution for the problems, sub problems. We will get the solution for the sub problems, all the sub problems, and we will combine that sub problem. So we will get the solution for the whole big problem. This is the fundamental behind the divide and conquer. Same method is used here for merge sort. Let us see using the example. Say we will take array A of size 6. Sorry, A of size 6. Our array is 1, 2, 3, 4, 5, and 6. This is our index. Sorry, this is our index. Total 6 elements. Okay. First element is 70. Second element is 7. Third element is 26. Fourth element is 10. Fifth element is 3 and 5. So our problem is now we have given an array of size 5. So we need to sort it in ascending order. So using a what is merge sort is? Merge sort uses a divide and conquer. Divide and conquer means this is one whole problem. So first we will divide this array into smaller part. So what we will do? We will divide this array. So how we will divide? So let us take L is equal to first index. So this is our L is equal to 0, and our last element of U, upper bound, lower bound and upper bound of the array. So how to divide? We have to divide this one. So we can divide it by L plus U divided by 2. So our L is, lower bound is 0 and our upper bound is 5. So divided by 2. So what we will get here? We get 2, 1, 5. But we consider only floor division. Only floor division. We consider only floor division. That is, we take only 2. So 2 is our midpoint. 2 is our midpoint. Okay. So our next array will be, this array will be divided into 2 in such that from lower bound to midpoint one array, from mid plus 1 to another array, upper bound another array. See here, our mid is 2. So 0, 1, 2. Till our midpoint, one array. From mid plus 1. Mid plus 1 is 3, 4, and 5. Up to upper bound is our second array. So index 0 is 70, 7, and 26. This is our first array. And 10, 3, 5. This is our second array. So again divide this array into subproblems. So in sorting, what we say? If the array contains more than one element, it is a problem, big problem. If an array has a single element, then it is a small problem. So we will divide the array till we get a single element in the subarray. So Again we need to divide this also till we get a single array. So see here, this is now our L and this is our U here. This is our L, this is our U. So again what we have to do? Again same method, L plus U divided by 2. So 0 plus 2 divided by 2. 0 plus 2 divided by 2. That is what? 1. So our midpoint is 1 now. So this array will divide like 0 to 1. This is first array. So 17 and 7. So next one remaining is 2. See, this array is not easy. We can this array contains only one element. So it is an easy problem now. So it is completely divided. So similarly this side. So our lower bound is 3 and upper bound is 5. So divided by 2. That is 8 by 4. Our midpoint is 4. So our next array will be 3 to 4 and 5 to 5. That is next only one element here, 10 and 8. See, again here two elements are there. Again the same method. Again we will take the lower one and upper one divided by 2. So here 0 plus 1 divided by 2, that is equal to 0.5. So our midpoint is equal to 0. So from 0 to 0, one element. 0 to 0, one element. That is 7. And 1 to 1 is another 7. Here also same. 3 plus 4. 3 plus 4 divided by 2, that is 7 by 2. That is equal to 3. So 3 to 3, one array, that is 10. And 4 to 4. See, here our array got divided into smaller problem. See here. What happened here? 17, 7 is also one separate, 2 is also separated, 10 is also, 3 is also separated, 5 is also separated. So here half part is over. Half part is means here we have what? Partition the array to a smaller problem. Now what is remaining? We have to merge. How to merge? We have to sort. We have to sort the adjacent side, adjacent elements, to sort it and merge it. So first we will see how we what partition the element by code. Let us see how we partition the element by code. Merge sort. So merge sort. A, comma, A is our array, comma, L, comma, U. We have to pass here what? Merge sort. A is our array, L is our lower bound, and U is our upper bound. Next, we have to check first if L is less than or equal to U. Because if it is one array, L will be equal to upper bound. Only one element. If there in array there is only one element, then upper bound and lower bound are same. So we have to check that whether more than one element is there. If yes, what we have to do? We have to find the mid is equal to L plus U divided by 2. We got 2. Next what we have to do? Merge sort. Merge sort. Array we have to pass lower bound, comma, or upper bound is what? Mid. First. Again merge sort A, comma, mid plus 1, comma, U. Okay. Next function is merge. So here A, comma, L, comma, mid, comma, U. So first what we will do, we will take one array. So this is our array and L is our lower bound, 0 is our lower bound and U is our upper bound. So what it will do now, see, now our L is 0, okay, and U is what, 5. We will find the mid. Mid is equal to what? Mid is equal to L plus 0 plus 5 by 2. That is equal to 2. Okay, mid is 2. So we will pass array, our whole array, and our lower bound 0, upper bound 1. Now we have found our mid 2. See, we still know this here over. Now what happens? Again the merge sort is called. Again the merge sort is called. So now what is the merge sort function here? What it do? It will do the partition. So here again see, A, our array is passed, L, lower bound is 0, and mid is what? 2. These three are the arguments. Okay? See here. Again merge sort is called. What it does merge sort? Here A, mid plus 1, 2 plus 1, that is 3, and 3 to U, upper bound 5. See. Again it is part merge sort. So see here, 0 to 2, this array, this partition, we got this array and we got this array. Again this is passed here, 0 to 2 and 3 to 5. So again we will try passing this argument to the merge sort, we will get this. Again here 0 and 1 are passed in next iteration. A 0, 1 is passed. Okay, and here I will show you the diagram. Like this, what happens here? The merge sort recursively calls and the array got passed in. See here. First, what happens? Our here merge sort MS. What is the lower bound? L is 0, upper bound is 5. This is called. So this is our function. And what happens here? See, what function is this? What it is? Merge sort. What happens in merge sort? L is passed. L is our 0 and mid is passed. 0 plus 5 divided by 2, that is 2. This is our first merge sort. Okay, and second merge sort. MS, what happened? 0, comma, sorry, not 0, mid plus 1. What is our mid? 2. 2 means 3, comma, upper bound is 5. And last, merge. Merge is 0, comma, 2, comma, 5. This is how it works. Now this will get divided. How it will get divided? See. Here again the merge sort is called. Merge sort again we have three functions. What? First merge sort. Here 0 is our upper bound, lower bound, and 2 is our upper bound. So 0 plus 2 divided by 2, 1. So 0 to 1 first merge sort, and next MS here. Yes, mid plus 1 is what? 2. 2 to 2. 4. And here what happens? Merge 0, comma 1, comma 2. Okay. See. Again recursively again merge will call here. MS merge 0 plus 0 divided 0 plus 1 divided by 2, 0.5. So 0 is our midpoint. So 0 to 0, 1, 5. Next MS. So what happens here? 1 to 1, because 0 is a midpoint and mid plus 1 is our what? Mid plus 1 is our lower bound, and U again 1 here. So again we have to merge 0 1 comma 0 comma 1. See, this is still here over. Again this is remaining. What happens? Over here merge sort. 3 plus 5 is what? 8. 8 divided by 2, 4. So 3 to 4 1 array. Next partition is ms 4 to 4, and we have to merge 3 4 4. Sorry, here 1. Next again here here it is 3 to 4 1 array and 5 to 5 1 array. 3 4 5. See here again this will again get divided, that is merge sort 3 to 3 plus 4 7, 7 divided by 2, that is 3. So 3 to 3 1 array. Next one is ms, so 3 to 3, next 4 to 4. Next what is that? Merge. Again we need to merge all this 3 3 3. This is our see. First there is a, in every merge sort there will be a 3 functions. See here. And first this is a merge. We are passing 0 and 5. So we are getting 3. We will have 3 functions. That is merge sort 1 for this array, merge sort for this array 1. Again for total merging this both array. Next see here. Again this will get divided. See 2 merge sort 0 to 1 1 array and 2 to 2 1 array. Next here this side here. Here also 2 array, 3 to 4 1 array, 5 to 5 array. Again 3 to 4 array will get divided. 10 3 to 3 and 4 to 4. This is how it works. Now what happens? Now here merge combine. So merge what happens? It will merge. I will write here. What happens? It will merge first 17 and 7 by sorting. So now what happens? 7 and 17. These two will get what? Combined. These two solutions are combined. So next our array will be 2. So 2, 7, 17 and 2. This will be sorted. This will be sorted. We will get array 2, 7 and 17. Okay. 17. So it is 26. 2, 7, 17, 26. 26. Okay. 26. So one side is sorted. So similar way here 10 and 3 get sorted. 3 here, 3 and 10 will get sorted. So again 5 this will get again merged. So 5, first element is 3, 5 and 10. Then this and this will get sorted. So we will get, so we will write it somewhere else. Space problem. So I will write here. These two array will get, here I will write first 3, 5, 7, 10, 17 and 20. This way it will combine. So we saw the program how to partition the array, but in merge also we have called merge function. How the merge function will work? Merge function will combine all the sub arrays. But how it will combine? It will combine in such a way that it is in a sorted order. So how it is sorted in? Again we will say in a merge code. We will see it in a merge code. Again we have different code for merging the elements. We'll see how it will work. Now we will see the code for merging. How we merge the partition array and sorting and merging that array. How we see? See, we have function merge. So what we will pass? We will pass the array a comma lower bound and mid comma upper bound. Okay. I is equal to N, K is equal to mid plus 1 comma and K is equal to, okay, because of space problem I have initialized in a single line. Next we check one condition, it is while I is less than or equal to mid and K is less than or equal to U. So what we have to do? Again we have to check one condition. If A of I is less than or equal to A of J, B of K is equal to A of I and I plus plus. Else B of K is equal to A of K and at last K plus plus and our while loop is 1. Again we have one more condition here. I will explain it later. If I is greater than mid, while J is less than or equal to U, B of K is equal to A of K plus plus. So K plus plus and K plus plus. Here else part. What else part? While I is less than or equal to mid, B of K is equal to A of I plus plus and K plus plus. So this is over. Yes, also over. See here what we have done. So, but this is a merge function. In this function, so it will start from here to here. Okay. See here. So what we have to do again? I will do something. See. Again, finally we got one. In each step, the merge will be done. So I am taking the last step where the merge is done. So last before sorting or merge, our step was here. Last two array was what? 7, 17 and 7, 17 and 26. This was sorted and merged. And again here, what was the array? 3, 5 and 10. So here our index was 0, 1, 2, 3, 4, 5. Okay. See here, these are 2 arrays. So we will take one more array of size 6. 1, 2, 3, 4, 5, 6. And we call it as array B or B. And this is our index 1, 2, 3, 4, 5, 6. See here, what we have passed? We have passed to merge A, comma L. A is our array. Whatever array is there, we have passed. L is our what? Lower one. That is 0. So now L is equal to 0. Next, mid. Mid is equal to what? We are passing the mid here. 0 plus here what we are doing? We are passing 0 plus 2. That is our mid is what? 0 plus 5. 5 divided by 2. Divided by 2 is 2.5. That is 2. So our mid is 2. And our upper bound is U is 5. See here, 5. So what we have done? We have taken value I and assigned it as L. Our L is what? 0. So I is also 0 because I is equal to L. So 0. So now I is here, that is 0 index. Next, J is equal to mid plus 1. J is equal to mid plus 1. What is our mid? 2. So J is equal to 3. Mid plus 1, 3. Okay, J is pointing here at 3, index 3. And now K. K is equal to L. What is the value of L? 0. So K is equal to 0. Okay, see here. What happens now? We have checked the condition. While I is less than or equal to mid. What it means? When I is less than or equal to mid. Mid is what? 2. I is what? 0. So mid is here. So I is less than 2. It will check if here one more element. If there is no here no element. So if I becomes 3, there is no element. So I will cross the array. So we are checking that condition within the array. Similarly, J is within upper bound. Let's within this array. It should not go out. So we are checking the condition. So I is less than or equal to mid. I is 0, mid is 2. Yes, less than or mid. Condition is 2. And J is less than or equal to U. J is 3, U is 5. Yes, condition is 2. So if the condition is 2, you have to come in the loop. So in loop, what is that? Here again, if condition. If A of I is less than A of J. If A of I is less than or equal to A of J. Again, we are checking the condition. A of I's value is 0. So A of 0 is 7. And J value is what? 3. A of 3. So A of 3 is 3 only. So less than or equal to 3. We are checking whether this condition is true. No, this condition is false. So what happens? This loop will not execute. If block will be not executed, else block will be executed. So this block. So what happens here? Here B of K. So sorry, here one K minus minus. Here what happens? B of K is B of K. B of K means K is 0. B of K means this array. B is this array. B of 0 is now K is pointing here. K is 0. So pointing here. B of K is equal to A of J. What is A of J? 3. So 3 is here. Understood? So next what happens? J is incremented. Sorry, not incremented. So now J becomes J is equal to 3. Now J is equal to 4. And I is equal to 0. J is equal to 4. And K is equal to, see, K also incremented. Now K is equal to 1. Okay. Next. Again what happens? Again it will go for while loop. I I is 0, less than or equal to mid, yes, condition is true. J is 4, 4 is less than 5, yes. So what happens? It will come for if condition. If a of I is less than or equal to a of j, a of i's value is 0, so a of 0 is 7, less than or equal to a of j value is 4, so j is now pointing here because 4 is here, a of j, so 5. Condition is false, so now it will come to else block. Now b of k is equal to a of j is 5, so b of k is pointed here now because k is 1, b of 1 is here, so what it will assign? False. And what happens now? J is incremented, so j is equal to 5 and k also incremented, k is equal to 2, I is still 0. Okay, again it will go to the loop. I is less than or equal to mid, yes. J is now 5, u is also 5, both are 5, but condition is less than or equal to is there, so condition is true. Again it will check. A of I is less than or equal to j. What is a of I? 7, because a of j is 7. A of j is now pointing 5 here, so a of j is 10. Now condition is true. Now this block will execute. So here what happens? B of k is equal to a of I. B of k is now what? Now k is 2 here. Now k is pointed here. So b of k is equal to a of I. A of I is equal to 0. So a of I is 7. So 7 will be and I will be incremented. Now I is pointed here and now I value becomes 1, j value is as it is 5, k value is incremented because it will come out of the loop and k plus plus will be done. K value is now 3. Okay, k value is now 3. Again it will go for check here. I is less than or equal to mid, I value is now 1, mid value is 2. Correct. J value is 5, u is 5. Condition is true. Now a of I is now pointing to 1, so 17. A of 1 is 17, less than or equal to what? A of j. J is pointing to 5. A of j is what? 10. Okay, 17 is less than or equal to 10. Condition is false, so it will come for else block. Now b of k is what? 3. So now k is pointed here. A of j is a of I is 10. 10 is noted here. 10 is put in the array. Now what? J is incremented. Now I is equal to 1, j is equal to 6 and our k is incremented again. K is equal to 4. Okay. Now see. Again it will go for the condition, while condition. While I is less than or equal to mid. Yes, I is 1, mid is 2. Condition is true. J is less than or equal to u, j is 6, u is 5. Now the condition is failed. So the whole this will be skipped now because the condition is failed. Now it will come for here. Now it will check. Because condition is failed because all the j values iterated and inserted in the array. Now only left with I. So now we are checking I is greater than or equal to mid. I is greater than or equal to mid? No. Condition is false. So it will come to else block. In else block what we will check? While I is less than or equal to mid. Yes, I is less than or equal to mid because I is equal to 1, mid is equal to 2. Now what we will do? B of k is equal to A of I. Where k, what is k now? K is 4. K is pointing here now. So A of I is where? I is at first position. A of, so here what happens now? B of k. Here A of I is 17 and I got incremented. I is pointing here. Now I value is equal to 3, j value is equal to 6, k value is also incremented, k value is 5. Again, any of this condition fails, all this will come out, and here only again. I is greater than mid. I is greater than mid? No. So else part. While I is less than or equal to mid? Yes. Condition is true. B of k. B of k is what? Now k is 5. Here it is, k is pointing here and Where is our I? A of I is 26. So P of k is equal to 26 is counted here. And I is incremented. I is now 4. And k is 6. K is 6. Now, again here, if I is greater than mid, yes, I is greater than mid, because I is greater than mid, and it will come out of the loop. So our program ends. See, now this B is a sorted array. In B, we have got sorted array which is merged. So we have taken the last step. So I am showing this. In every step, the same process will happen, and the array got sorted and then merged. Though here what happens in merge sort, the array is divided into what? 2 parts. Not 2 parts, sub parts, until in each array there are only one element, until it will divide the array into sub arrays. And what happens again, after getting single element in the arrays, sub arrays, we will sort and merge the adjacent arrays, and we will get the solution, that is sorted. Here divide and conquer method is used. I hope you understood. Thank you.